Combustion engines cannot start by themselves. In times gone by, the driver had to use a crank handle. Today, it's much easier to drive off. With only a quick push on the start button, the driver sets a complex procedure in motion. When pressing the start button, current flows from the battery via the ignition switch to the starter. The current activates a solenoid switch, creating a magnetic field. A magnetic core is pulled into the magnetic field. The core movement sets a lever mechanism in motion. The engaging lever presses the starter pinion towards the flywheel ring gear. To prevent the pinion teeth from pushing onto the ring gear teeth, the pinion is driven by a thrust screw motion. Its teeth screw into the flywheel's teeth gaps. This is where the starter's name comes from. It's a pre-engaged thrust screw drive starter. When the pinion and the ring gear completely mesh, the starter has engaged. Right at this moment, the magnetic core reaches its final position. It pushes against a contact plate, closing the contact between the battery and the starter motor. Current now flows from the battery via this cable to the starter motor, and via the housing back to the battery. The electric circuit is closed. The current causes the starter motor to spin. The spinning motion is transferred to the pinion. The pinion turns the flywheel's ring gear, which in turn drives the crankshaft. The engine starts. The vehicle engine now rotates much faster than the starter pinion. This high engine speed could over-rev the starter motor and cause damage. To prevent this from happening, the pinion is disengaged from the starter motor by means of a freewheel. When the driver releases the start button, the electric circuit between the battery and the starter will be interrupted. A return spring installed in the solenoid switch pushes the magnetic core back into its initial position. The pinion disengages. The electric motor switches off. Power is transmitted from the starter motor via gear wheels to the vehicle engine. Within this process, transmission ratios play an important role. Depending on the particular engine starter combination, different transmission ratios are applied. While the small starter pinion has to rotate 10 times, for example, the large gear wheel of the flywheel only rotates once. Vehicle engines which require more force to be rotated need to work with a stronger starter. There are two possible ways to do this. It's either possible to install a larger starter or a stronger starter with an additional transmission gearing. Because of its design, the most suitable solution here is the use of a planetary gearbox. This type of gear set consists of several gear wheels. The sun gear is driven by the starter motor shaft. The planet gears circulate on the teeth of the fixed ring gear. They transfer the force to the shaft with the mounted starter pinion. That's how the planetary gear converts the high starter motor speed to the low pinion speed. The pinion itself is therefore subject to higher forces. That's how even a small starter motor can start the vehicle engine without any problem.